All right, so this chapter has how many types of numericals? Five. Okay, the first one what we did was using Gay-Lussac's law, where we have to balance the equation, find out one volume. That was Gay-Lussac's, right?
Yes.
Okay. Second was Avogadro's law. For Avogadro's law, you had those three things, right? The volume of 1 mole, the number of molecules in 1 mole, and the weight. Next, third one was the easiest one, which is percentage composition. Right, that's what we did. And then the next one is something to find empirical formula and molecular formula. That's what we're going to do today. And tomorrow, the next chemistry class is the most difficult one, chemical equations. That's the most confusing. Okay, so we will do empirical formula now. Okay, listen carefully, everyone, because this empirical formula is easy, but a lot of steps are there and a lot of calculation again. Now, what is the meaning of this word empirical formula? Have you heard of it? Do you know what it is? Empirical formula is the simplest ratio of elements in a compound. For example, sugar. What's the formula for glucose or sugar? C6H12O6. This is the molecular formula. What does this molecular formula tell you? What does it tell you? It tells you the number of atoms in that molecule, exact number of atoms. Like there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Now the empirical formula, in the empirical formula, it just shows you the ratio of the atoms, the simplest ratio of the atoms. So like if you can cut the 6, 12 and 1, 6, 12 and 1, 6, 12 and 6, you can cut this in 6 tables. So this will get 1, 2 and 1, right? You can cut this in 6 tables, so you get 1, 2 and 1. So if you represent it like this, C is 1, H is 2 and O is 1. This is the empirical formula. So representing the atoms in their simplest whole number ratios is the empirical formula. Do you understand that, everyone? Okay. Now let's see another element. H2SO4, sulfuric acid. This is the molecular formula. What would be its empirical formula? This is 2 hydrogens, 1 sulfur, and 4 oxygens.
HSO2.
HSO2?
Yes.
What do you all say? What do you all think? No? One says no. What do you think, Leah? Don't smile. Tell. Can we cut this 2, 1, and 4? Can we make it smaller? Cutting means you should cut everything. Can we cut all of these numbers and make it smaller? No, we have a 1. You can't make 1 smaller. So this itself is the empirical formula also. You can't make it smaller, right? So the molecular formula is the empirical formula over here. Understand? Not every molecular formula we can make it into a smaller ratio. Is there any other formula that you can make it smaller? No, actually, because when we write crisscross method itself, we cut it there itself. No, for example, magnesium carbide. Okay, magnesium's valency is 2 plus and carbon is 4 minus. So we don't write it as Mg4C2. This is if it was directly crisscross method. Then we can cut 4 and 2 and make it smaller. But when we make the formula itself, what we do? We cut it here itself. No, 2 and 4. So we write 1 and we write 2 and we already make it into a small form. So directly it is already Mg2C1. So here the molecular formula and the empirical formula is same. Right. So most of the time you don't have something like this, but there are some cases like copper sulfate, CuSO4.5H2O. Okay. So here you see oxygen is in different places. So when you see the total number of oxygens, total number of hydrogens, and total number of everything, sometimes it's possible to write it in a smaller ratio in an empirical formula. Okay, but most of the time, if it's a normal formula like this, then it is already in the smallest form, except some examples like sugar. Okay. Okay, so let's see how to do this. How to do these sums on this. Okay, before that, you just write down this example of sugar. and definition for molecular formula and empirical formula. I've written the definitions: molecular formula, actual number of atoms in a molecule. Empirical formula, simplest whole number ratio of atoms in the molecule. Done? Okay, before we get into how to solve this, let's find the molecular formula for sugar. And let's also find the empirical, sorry, what did I say? Molecular formula, no. Find the molecular weight of sugar and also find the empirical weight. How do you find the molecular weight? You'll add all the weights, no? Same way, find the empirical weight. That means the empirical formula's weight. You understand? Okay, do that. Find the molecular weight and the empirical weight.
Anna, can you repeat it again?
I'm telling to find the molecular weight of glucose and the empirical weight of glucose. Molecular weight of glucose means you will use the formula, molecular formula, C6H12O6, and add all its weights. Carbon's weight is how much? Carbon is 12. So 12 into 6, because there are 6 atoms. Hydrogen's weight is 1. 1 into 12. And oxygen is 16 into 6. Yes? Carbon's weight is 12. Hydrogen's weight is 1. Oxygen's weight is 16. Okay. All right. Find the molecular weight. 180.
Yes.
Now find the empirical weight. Anyone else got 180? Okay, Gloria, Nathan, Hannah, Ryan.
Done, Anna.
Yes, Anna, I got 180.
Find the empirical weight now.
180 and 30.
Okay. Sure. I wrote a spelling mistake in empirical. It's not Oh, I wrote correct only. I thought I wrote wrong. Okay. Got 30? If you divide these two, 180 divided by 30, what are we getting? Molecular weight divided by empirical weight. 180 divided by 30, what are we getting? 6.
6.
This 6 is called N. We call this N. N is 6. Where do we use this N? If we multiply this N with the empirical weight, with the empirical formula, we will get the molecular formula. See, we cut this with 6, no? In 6 tables we cut. So that N is 6. If we multiply 6 with every element over here, what do we get is? We get the molecular formula. We saw that. So we can make one more formula. That is empirical formula multiplied with N, like this. We will get what? The molecular formula. You understand? Okay, so I've shown you two formulas. One is a formula to find N. How do we find N is molecular weight divided by empirical weight. That we got 6. And here we have another formula. That is, if you multiply this N with the empirical formula, we'll get the molecular formula. Okay, we're going to use these two formulas in the sums. So write down these two. Shall we move ahead? Now let's look at a question where we have to find the empirical formula. I'll write down the question here. This is example 8 in your books. Those of you who don't have books, I'm writing the question here. a compound. Right, all of you write on the question. Okay, so there's a compound. It has 3 elements in it. What are the 3 elements? So something like sugar, right? But there are so many, there are millions of compounds that have these 3. So it's not sugar, okay? Now it has 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Okay. Now what we're going to do right now is we're going to find the empirical formula. There's no way to directly find the molecular formula, but we can find empirical formula. After that, we will see how to find the molecular formula. What is the question? Yeah, but what we're doing right now is not to find molecular formula. It is to find empirical formula. Is that clear, everyone? Okay, so we're filling our table. First column is the elements, the 3 elements. Second column is the percentage composition of each of the elements, which is given in the question. Third is the atomic mass of the elements, which might be given in the question. Mostly they should give the masses of each of these elements. Okay. Now the next column is the ratio. It's called atomic ratio. To find this atomic ratio, we have to divide the percentage with the mass. That means 40 divided by 12. For the next, it will be 6.7 divided by 1. And for the next, that is 53.3 divided by 16. Okay, so here there's a division that you have to do. Okay, so do them and tell me what answer we're getting. So we are getting around 3.33, 6.7, 3.33. Okay, we don't go with exact values. We should be able to round it off a little bit here and there to get the answers. Okay, all right, so this is what we're getting: 3.33, 6.7, and 3.33. Now they're not whole numbers, they're all decimal numbers. We got the ratio. This is the ratio. Okay, 3.33 parts of carbon, 6.7 parts of hydrogen, and 3.33 parts of oxygen. That's the ratios. But these ratios are not in whole numbers. How do we make them as a whole number? Huh? Round it off. That's too much to round off. It'll get lost. I mean, the ratios will get lost. It'll get wrong. Into 10 or into 100. But there's an easier way. Easier way is divide each of them with the smallest ratio. Which is the smallest out of these 3? Out of these 3 numbers, the smallest number is 3.33. So divide each of them with 3.33. So 3.33 divided by 3.33. See, we're getting 1. Next, 6.7 divided by 3.33. Don't go with exact values, you will get decimal numbers. But if you see, double of 3.33 is what? 6.66. That is very close to 6.7. So we're rounding it off and taking it as 2. If we divide exactly, what's going to happen? Look, 6.7 divided by 3.33. What are we getting? 2.01. But we're rounding it off. Instead of 2.01, we're taking 2. And the last one, 3.33 divided by 3.33, that is again 1. So now we've got the ratios in whole numbers. Okay, this column is called simplest ratio. Write this down. Okay, so now we have carbon is 1 part, hydrogen is 2 parts, oxygen is 1 part. So therefore empirical formula is what? Carbon is 1 part, hydrogen is 2 parts, oxygen is 1 part. Same like sugar, right? CH2O. Okay, so that's it. Did you understand how to do empirical formula? 5 columns. First is the name of the elements, then the percentage composition, then the weights, the mass or mass number or atomic weight. Then we find the ratio by dividing. We will get a decimal number. To get that into simple whole numbers, what we have to do is divide with the smallest one out of those, and we will get it in whole numbers. And then write that as a ratio, and that is your empirical formula. Okay, now the question is saying find the molecular formula. So we have written few formulas here. We have empirical formula. To find molecular formula, we need to multiply with n. How do you get this n?
Yes, to find a molecular weight.
Molecular weight divided by empirical weight. Right. Now in the question, they have given the molecular weight. See, what is missing now is the empirical weight. Can we find empirical weight? Yes, we have the empirical formula. From that, we can find the empirical weight. In fact, we found the empirical weight. What is empirical weight? In the previous, we did know the same thing. Huh? How much was it?
30.
30. So we have empirical weight 30 and we have molecular weight which is given in the question 60. Therefore, n is how much?
20.
60 divided by 30. 2. Okay, we got n. So now we can find the molecular formula. So molecular formula is what? Empirical formula multiplied with n. That is CH2O multiplied with 2. So that is C2H4O2. That's your answer. Clear how to do it? Write it down. Next question, write down. What is different in this question from the previous question? They didn't give molecular weight. They gave vapor density. So what is this now? So it's very simple. Take vapor density. How much is it?
39.5.
Multiply it with 2. You will get the molecular weight. That's it. So understood? Multiply vapor density into 2, you will get the molecular weight. So that is your third and last formula. See, we have written two formulas. One was to find n, one was to find the molecular formula. The third formula is to find
Molecular weight.
molecular weight. What's the formula? Vapor density into 2. Write this down as your third formula. So in this, once we get the empirical formula, first we will find the molecular weight, right, by doing vapor density into 2. Then we can use this where? In this formula, molecular weight. Empirical weight we have to find using the empirical formula that we found. Divide those two, you'll get n. So this is second what we'll use. And then third, we will use this formula to find the molecular formula. Okay. All right. All of you do this by yourself now. Make a table the same way. Put all the values in the table. Follow the same steps. Did you get it? Answer?
First one I got 632.6.
Think 75 divided by 12. It will be 632. What did you all get? Clear? Sure. It's 6.3 only. It'll come 6.32 only. Why 30? 3 and then you have to put in 9.
Empirical formula C5H5N.
What was that, Gloria? Who's that? Wait, your voice is breaking. I can't hear you. Okay. See, you're supposed to get 6 point around 32 only is coming. Okay. Look, it's coming exactly 6.32 actually. 75.92 divided by 12. How much is this? 6.326. That means 6.33. But yeah, let's take 6.32 because we already have a 6.32 here.
I got 632.6. So I
632.
forgot to put the point.
Yeah, you didn't put the point. That's just 600. How it will come? right? Okay, so 6.32, let it be same. And what about the 17.76? 1.221 you got? Anyone else? 1.26 it's coming.
Yes, and I also got 1.26.
Yeah, 1.268. Anyone else? 268 is almost 1.27. Okay. All right. So say let's take 1.27 because when we take three decimal places and round it off, that's what we're getting. Okay. So this, let's now divide. What is the next column? Okay. So simplest ratio. You're dividing each of this with what? 1.27. You go take the paper now. Let's hold your paper. Oh, sorry. So that's one. What about these? So that is 632 divided by 127. Okay, so 127 into 5. 5 sevens are 5 twos are 6. See, it's coming close to this. See, we don't need to go to decimal levels and all that, but you see, we just need to get close to 632. And 127 into 5 is coming 635. Huh? So 4.9 something it will come because it's very close to this, no? Understand? So we can approximately take it as 5 because it's 4.9 something. Anyway, we're going to round it off. This also, look, let's use the calculator. Let's see what we're getting. 6.32 divided by 1.27. How much is that? 4.97. See, when it's so close to 5, we round it off. If it's 4.8, we can't round it off. If it's 4.9, you can round it off to 5. If it's 5.1, you can write it as 5. If it's 5.2, no, that's too far. In fact, you won't get 5.1 also. You'll get 5.01, 5.02, 5.03, something like that. So it's very close to the whole number. Okay. All right. So you got your simplest ratios. Now you can write down your formula.
How did you make that calculator?
Put start and type calculator. Continue the rest and tell me the empirical and the molecular formula. So empirical formula is C5H5N. Then we need to find molecular weight. Molecular weight is vapor density into 2. That's 39.5 into 2, which is 79. Then we need to find empirical weight. Empirical weight is, so for C5H5N, so that is 12 into 5 plus 1 into 5 plus 14 into 1. So 60 plus 5 plus 14, which is 79. See, both are same. Molecular weight and empirical weight is same, which means the formulas are same. But anyway, you need to write it down. So you need to show it. N is molecular weight divided by empirical weight. It is 79 upon 79, which is 1. Okay, all right. I hope everyone's clear on how to do this. It's quite easy. Only thing, the division is there. Right, you'll get decimal numbers, so you have to be very careful in that and do it fast so that you won't waste time. The homework from this I've sent it on the group already. That is, write down, mark down the questions. Exercise 5C, 8, 9, 10, 11. What book is this? 8, 9, 10, 11. So the ones who didn't do the homework, which is I think most of you, you have to do all today's homework and yesterday's homework. Don't keep pending homeworks. It adds up. Then instead of spending 1 hour, you'll have to spend 2 hours. All right. We'll do maths.